Task. At my daughter's house, they're on irrigation water, which comes in a pipe in their backyard, which goes into a sprinkler pump and uses it for sprinkling the lawn. But the problem is that the water is unreliable, and you shouldn't run the pump if there's no water in the pipe. So my project is to measure the amount of water in the pipe, and at first we're just going to gather data. Down the road we'll use that data to actually control whether or not the pump can turn on. So what you're looking at here is, that's an Arduino Nano, and the pipe, this simulates the pipe. The 5 screws are essentially switches, resistor switches. When there's water in the pipe, the circuit is closed between the bottommost screw and each of the screws up to where the water level is. So this Nano right here is monitoring which of the switches is closed, and I can actually simulate closing of the switch just with the resistance of my hand. If you watch the red LED change its characteristic, so that's saying that it's number 4. Change it to number 5. It blinks a little bit faster, and it blinks 5 times. This Arduino Nano is sending its data out via an NRF24, which is a 24 gigahertz wireless RF transceiver. And this guy is running remotely on simply a 9-volt battery. When I put it into service, I'll have one of those solar charged batteries, so it should run pretty well with that. On the receiving end, we have an Arduino Uno with the NRF24 transceiver. Now the breadboard is simply an interface. The Arduino is controlling the NRF24, and output-wise, when the signal, the Nano is sending just a little text message that says which level is being triggered. So this guy receives that text, then the Uno interprets that text, and then turns on one of the LEDs, which indicates the water level. So now what I'm going to do is, once again, I'm going to simulate one of the switches. And there you can see the light came on. Now I'll change switches. It's on a 2-second loop. There you can see it changed. I'll change again. So there. So the Arduino is receiving the message. The Arduino Uno is receiving the message and indicating on the LEDs which water level is being set. Now I tried to get, the next thing is the Raspberry Pi. That's a Raspberry Pi Model B Rev 2. I tried to use the NRF24 transceiver on the Raspberry Pi directly. I just couldn't get it to work. That's a whole different story. Anyway, with the 4 LEDs being engaged or disengaged, that's a very simple task to go to the GPIOs on the Raspberry Pi and write a simple Python program that monitors those 4 GPIO pins. And so here's what happens when you run that program. Now I'll turn on one of the water levels. There you can see that's number 3. Switch it to 2. Switching it, there it goes. Switch it to 1. Okay, back up to 5. There you go. Run it again. Start with 5. We'll start with the top level. Okay, down 1. Down 1. So the idea is to collect the data from the pipe and With the Raspberry Pi, I can take that data and I can create a web page that will create a chart that shows you the times of the day when the water level changes and where it is, which then will know how to set the sprinkler timers.